problems, I do recommend that you try these yourself because they are just geometry. There's no calculus involved here. Because you are going to have to do all of this for each of the problems that you do for 831 to 833, which is calculating volumes of cross sections. It's okay, you don't understand what that means yet. You will in the next lecture. So draw a picture of each figure described with B, meaning your base, in the horizontal direction. Then we're going to calculate the area in terms of B. So you don't need to memorize these. You just have to understand how to do basic geometry. It's going to be circles, triangles, squares, rectangles, like it'll be easy things. You will have to use like Pythagorean theorem occasionally, but besides that, it's pretty much just, geometry. So a circle with diameter B. So if I have a circle, the diameter is B. Okay. Then what would the area be? Well, area of a circle is pi r squared. Okay. Radius is half of B, since it says the diameter is B. So that's going to be pi over 4, 2 squared is 4, times B squared. And that would be my area. And I do want you to draw B in the horizontal. That will make more sense to you in the next lecture. But you should draw B horizontally. So for this one, we have a quarter circle. Oh, that's not a quarter circle. I know what a quarter circle is. There we go. Quarter circle with a radius of B. Okay, so the quarter of a circle is 1/4 pi r squared. In this case, the radius is just B. So it's 1/4 pi times B squared. Or pi over 4 B squared. In this case, the answer is the same as 7, but that's just a coincidence. It's not always the same. An isosceles right triangle of... Okay, I should go back. The reason I'm saying it's not always the same is because I said a quarter circle with a radius of B. In this case, the diameter was B, and it was a full circle. And just based on the math, it ended up being the same answer. But it's not like every circle thing I give you with B is going to be pi over 4 B squared. If I gave you a semicircle with a diameter B, I would not get this answer. Or if I got a semicircle with a radius of B, this would not be the answer. Okay, an isosceles right triangle. So isosceles means two sides are the same, and a right triangle, it's like this. So it's isosceles, which means these two sides have to be the same, and both of those sides are B. So we have an isosceles right triangle with a side length B. The area of a triangle is 1/2 base times height, but my height is also B, so it's 1/2 B squared. Easy enough. A square with a diagonal length B. So remember, I want your B to be in the horizontal direction. So if the diagonal of a square is B, it's going to look like this. Okay, so let's start with the area of a square. The area of a square is side squared, so I'm going to let that side be S. And I need to solve for S in terms of B to plug it into my area function. Well, I have a right triangle here, don't I? So I can say, okay, well, S squared plus S squared is equal to B squared. 2S squared is equal to B squared. Divide by 2. And S squared is B squared over 2. So area is equal to B squared over 2. So I just had to use Pythagorean theorem to solve for what S squared actually is. I didn't solve for S and then square it. I just figured, okay, well, it's S squared already, so I'll just leave it. An equilateral triangle with side length B. Okay. The area of a triangle is 1/2 base times height. Now, in this case, my height is not B. Now, if you know your special right triangles, you can use special right triangles to solve this. Or you can say, like, if I do kind of a cutout of half of this, this is 1/2 B. This is H and this is B. And I could just use Pythagorean theorem. So H squared plus 1/2 B squared is equal to B squared. I'm solving for H to be able to plug it in here. So H squared is equal to B squared minus B over 2 squared. H squared is equal to B squared minus B squared over 4. H squared is equal to, get a common denominator, that's 3B squared over 4. So h is equal to, take the square root of both sides. Technically it's plus or minus, but because we're talking about side length, it's going to be a positive. So that's going to be root 3 times the square root of b squared is b over the square root of 4 is 2. So my height is I just took the square root of this whole thing, right? The height is root 3 over 2 times b. So the area would be 1/2 b times root 3 over 2 times b. So the area is root 3 over 4b squared. Okay. So again, you need to be able to come up with this yourself. If you know your special right triangles, you would know that the height is root 3 over 2b because it's this side length times root 3 and this side length times 2, if you know your 30, 60, 90 triangles. But if not, just use Pythagorean theorem. Pythagorean theorem works just fine here. All right, and then a right isosceles triangle of hypotenuse length b. Okay, so right isosceles triangle, the hypotenuse length is b. Okay, so then what are these two sides? Well, let's call them S. So the area of a triangle is 1/2 base times height, which in this case would be s squared. Okay, and then I can use Pythagorean theorem, s squared plus s squared. We already did something very similar to this because a right isosceles triangle with a hypotenuse length b is half of the square with diagonal b. But again, I don't want you to memorize these or have this in front of you. You just have to know using Pythagorean theorem or your other geometry formulas how to find the area. So that's going to be b squared over 4. Okay. So again, sometimes we use Pythagorean theorem. Sometimes we just have like basic formulas. I do recommend you draw b as a horizontal because in the next lecture, you're going to be using b in the xy plane and it will be like shapes coming out. So I'll give you like a little preview here. If this is the xy plane and you have like a semicircle with a diameter of b coming out of it, so b is on the xy plane, and then you have a semicircle like kind of coming out of it. And this is a 3D figure. Maybe it's hard to see, but I've got like a semicircle. Or if I had a full circle, I'd have half a circle above the plane, and then I'd have like half a circle below the plane. But the idea is the base is in the plane. So that's why I always want B to be like your horizontal, because it's what's lying in the plane for this next, volume section that you do.